Hey Algebra, today we're going to talk about multiplying and dividing rational expressions. Before we do that, let's start with a review of factoring. Remember, our first rule of factoring is to look at each term and see if we can find the greatest common factor. So in number one in your notes, we have 2x to the third minus 4x squared. And it looks like the greatest common factor is 2, and we can also take out an x squared. So if our greatest common factor is 2x squared, what we can do is we can factor out the 2x squared. Remember, that really means we're dividing each term by 2x squared. So 2x to the third divided by 2x squared leaves me with an x. And 4x squared divided by 2x squared leaves me with a 2. If I went back and distributed, 2x squared times x is 2x to the third, minus 2x squared times 2 would be minus 4x squared. Example number 2, I don't have a greatest common factor. I have a trinomial, so I'm going to guess and check. It's going to factor into two binomials. Well, x times x is x squared, and what multiplies to give me negative 28 but also adds to be negative 3? That would be negative 7 and positive 4. Problem number 3, similar to 2, except it's a special case. We have difference of perfect squares, so I would take the square root of each term. Square root of x squared is x, and the square root of 36 is positive 6 and negative 6. If we look at the next three problems, that has us go over exponents. So when we multiply, we actually add the exponents, so that would be x to the 8th power. When we're dividing, we subtract the exponents. 6 minus 2 would be x to the 4th. Here we're going to subtract also, but since there are more x's in the denominator, we're going to go 5 minus 2. That gives us x to the 3rd. But again, there's more x's in the denominator, so it's 1 over x to the 3rd. Okay, let's look at the next problem. What's a rational expression? Well, a rational expression is basically any expression written as a ratio. So it's going to have a fraction. It's going to look like a fraction. If you look at the example on your paper, we have 2x over 7x plus 5. And what we're going to do here in the next three examples is we're going to simplify each rational expression, and then we're going to say where is the denominator undefined. Recall that you cannot divide by 0, so any x value that makes the denominator 0, we would say the rational expression is undefined there. So for example, number 7, there should actually be a parentheses right there. So now we're good to go. Okay, so we have 2x times the quantity of x minus 5 over the quantity of x minus 5 times the quantity of x minus 1. Well, I can see that they both share an x minus 5 quantity, so I'm going to cross those out. That leaves me with this. Now I know they both share an x, but because there's a minus sign here, x minus 1 is considered one quantity. I can only cancel out that x minus 1 if there's another x minus 1, which you can see there's not. So that's completely simplified. Now let's see where x cannot, what x cannot be, because that would make the rational expression undefined. So I can start here. If x is 1, 1 minus 1 is 0, and then 0 times, this would be negative 4 if x was 1. 0 times negative 4 is 0. So x cannot be 1. But also, even though I crossed this out, in the original problem we had x minus 5, x can also not be 5, because 5 minus 5 would make this 0, and 0 times 4 is still 0. That would make the denominator 0 as well. So there's your simplified expression, and that's what x cannot equal. Example number 8. I can see that they share a y plus 7, so I can cancel those out. But then if you look here, y squared minus 9, I can simplify that. Actually, I can factor that. So it's going to look like this. That will factor. That's difference of perfect squares. So I take the square root of y squared and the square root of 9. That's plus and minus 3. And then they share a y minus 3. So that'll cancel out. So that leaves me with 5 over y plus 3. Now there are actually 3 different y values that will make the denominator 0. -7 will make the denominator 0. -3 and +3. So y cannot equal -7, -3, and +3. Moving on to number 9, there's two different quadratics that you have to factor. The top one, what multiplies to give you -12 and adds to be 1. That would be x plus 4 times x minus 3. The denominator, what multiplies to give you 12 and adds to be 7. That would be x plus 4 times x plus 3, both positive. Now this time I'm going to try it a little bit different. Instead of crossing out what they share in common, I'm actually going to say what x cannot be first and then go back and cross out later and see if that works for you too. Okay, x cannot be -4 and x cannot be -3. So x cannot equal -3 and -4, and then I can cancel out. They both share an x plus 4. So the final answer here is x minus 3 over x plus 3. And there's what x cannot equal -3 and -4. Let's try dividing. Of course, everybody knows that before we divide, we want to multiply, like in example number 10. All right, so if we are we just simplified rationals. Let's see what happens when we multiply rationals. Well, just like fractions, you want to multiply across. So the numerator times the numerator over the denominator times the denominator. But before I do that, what I'm going to do is I'm going to simplify the coefficients first. So I see here that I have a 4 and I have a 2. Those are both divisible by 2. Well, 2 divided by 2 is 1. 4 divided by 2 is 2. 5 and 15 are both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And actually that 8 to the third is still there. Did not mean to cancel that out. Okay, so let's multiply across. We have 2 x squared y a b to the third over 3 a to the third b to the third x y squared. Okay, all I have to do now is to simplify the variables and I should be done. So it's still 2 over 3. Here we have, this is actually an x squared. So we have x squared over x, that's 2 minus 1, which is 1, and there's more x's on top, so that would stay there. The y's would be 2 minus 1, and there's more y's on the bottom, so that would stay there. The a's, 3 minus 1, which would be 2, and there's more a's on the bottom, so we would leave that there. And the b to the third and another b to the third, those would cancel. So this one is finished. Okay, example 11, very similar, except I have some factoring to do. So if I look at the numerator, what multiplies to give me -8 and adds to be 2, that sounds like -4 and +2. So we're going to go x minus 4, x plus 2. In the denominator, what multiplies to give me +3 and adds to be +4, that's going to be 3 and 1. So x plus 3, x plus 1. Now, this is interesting here. I have 3x plus 3. We're going to go back to greatest common factor. They share a 3 in common. So I'm going to factor out that 3. Then remember, I divide each term by what I factor out. So 3x divided by 3 is x. 3 divided by 3 is 1. And then the x minus 2 stays where it is. So what can I cross out? Well, I can cross out an x plus 1. And I can cross out, actually I see a mistake there. -4 and 2 would give me -2. So this should have been +4 and -2, because 4 plus -2 is +2. So in that case, since there's 2x minus 2's now, I can cross those out. Okay, so that leaves me with 3 over x times the quantity of x plus 4. 3 times the quantity of x plus 4 all over x plus 3. And I cannot cancel anything out because those are different quantities, and these 3's can't cancel out because the 3 on the bottom is attached to the x. All right, moving right along, let's divide. Example 12. Well, we remember a long time ago when we learned how to when we learned how to divide fractions, we actually multiply by the reciprocal. So we're going to take the reciprocal of this here, which means we're going to do 4a over 5a times the reciprocal, which is 15b squared over 16a to the third. Then it becomes just like problem number 10. So I am going to divide this by 4 and get a 1. I'm going to divide 16 by 4 also and get a 4. 15 and 5 are divisible by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. Multiply across. So that leaves me with 3ab squared over 4a to the fourth. So my final answer, because I can do 4 minus 1, which is 3, a to the third. A to the third would be on the bottom because there's more a's there, and the b squared would stay on top. 3b squared over 4a to the third power. All right, example number 13 is not there, but I'm going to put the answer down now. So if you want to pause the video, try example 13. The answer to example 13 is 4SD. Let's go to example 14. All right, same idea, multiply by the reciprocal. So x minus 3 over x plus 1 times the reciprocal. Now I'm going to factor this to save a little bit of space and time. So the numerator is 1 minus x squared. That's difference of perfect squares. So I take the square root of 1, which is 1, the square root of x squared, which is positive x, and negative x. So this will be my new denominator. What multiplies to give us positive 3 and adds to be negative 4. That's a double negative. So we're going to look at x minus 3 times x minus 1. And let's see what I can cross out this time. I can get rid of an x minus 3. These are both x plus 1s. So that gets me down to 1 minus x over x minus 1. Now it looks like I'm finished. However, take a closer look. Here we have a positive x, here we have a negative x. Here we have a negative 1, here we have a positive 1. So those are opposites. So if I factor out a negative 1 from the numerator, 1 divided by negative 1 is negative 1. Negative x divided by negative 1 would be positive x. Watch what happens now. In my problem now, I have a positive x and a positive x. I have a negative 1 and a negative 1. So now those are the same. I can cancel those out, leaving me with just negative 1. Let's move on to the next example. All right. Actually, the next example is example 15, and if you want to pause it and try it, I have the answer for you. I'm going to write it right over here. The answer to number 15 is x plus 2 over x plus 4. All right, finally, a complex fraction. A complex fraction is a fraction within a fraction, or it has a fraction in either the numerator or denominator or both. So it looks something like this, and pay close attention. Number 16 on your paper is different than how it should be. On your paper, I believe it says 5x minus y. Please change that to x minus 5y. And then I'm going to rewrite this, a little bit easier way for you to see. So if I rewrite this, this would be x squared over x squared minus 25y squared divided by x over x minus 5y. So now it looks exactly like problem number 14, one just like that. And we're going to treat it the same way. So we are going to multiply by the reciprocal. So how about we do x squared, and then this is difference of perfect squares. So this would be square root of x squared is x, square root of 25y squared is 5y. And then remember it's positive 5y and negative 5y times the reciprocal, which would be x minus 5y over x. Okay, what can I cancel now? Well, I can cancel the x minus 5y's, and then that will leave me with x squared over x plus 5y times x, but then I can do 2 minus 1 because I can subtract those exponents and just get an x left over on top. My final answer, x over the quantity of x plus 5y. Number 17 is not on your paper, but I would like you to try it. It's another example just like number 16. I will give you the answer to number 17. If you want to pause it and try it on your own, you may. The answer to number 17 is x plus 8 over x minus 9. That's the answer to number 17. Thank you so much for watching Multiplying and Dividing Rational Expressions. Please stay tuned for the next video, which is adding and subtracting rational expressions. Have a great day. Thanks, guys. Bye.